Ready-made maths YouTube mathematics training. Teaching assistant and teacher training in mental mathematics. Today is day 2 and we're going to be looking at the strategy double and adjust.
Hello and welcome to day 2 of the Ready-made Maths YouTube channel. What we're looking at this week are mental arithmetrics. Yesterday we started with the first mental mathematics strategy, which was number bonds. I hope you found the activities useful and were able to have a good practice back at home after watching the videos. What we're going to be looking at today is the second of the strategies. If we look at the board over here, today's strategy is double and adjust. You can see by looking at the board a range of calculations starting with a very simple kind of early years key stage 1 calculation, 3 plus 4, and building up to a decimal calculation, 1.5 plus 1.8. All I'd like you to do to begin with is just look at the 6 calculations, obviously look at the title of the strategy, double and adjust, and just try to think to yourself, if I wasn't able to work those out in my head, if I didn't know the answer straight away, which I'm hoping we do for those first few, what strategy could I use to help me? What number facts do I need and how can I use them? Just pause the video now and have a quick look at those calculations. Okay, looking at the 3 calculations that I've underlined in red. Look at the calculation 5 plus 7. If I was to ask a child in, let's say, early years to work out 5 plus 7, what they'd probably do is count out 5 things, count out 7 things, and then count out 1 to 1 or 12 in order to get the answer. How would that develop in year 1? Usually, the child would think, oh, 5 plus 7, I've got to put the biggest number in my head. So they put the 7 in their head, they often put 7 on their fingers and do that, or go 7, and then they count on 8, 9, 10, 11, 12. How does that develop as the children move into year 2 and they're dealing with a calculation like 7 plus 8 or developing it up to 25 and 27? Well, again, for 7 plus 8, you do often see children in year 2 or 3 or even year 4 still putting 8 in their head and going 9, 10, 11, 12, 13, 14, 15. There's even children in year 5, 6 that tend to count everything on their fingers. What we're going to look at today is how can we move away from finger counting into using near doubles. Finally, looking at 25 plus 27, if you gave that to a child in year 2, what sort of strategy are they likely to use? Well, if they've been taught the column method, they may well use that. More likely, they'll do a partition. They'll do 20 and 20 is 40, and then we're back to the 5 and 7 again, which again, usually you'll see the children on their fingers counting up that to get the 12. They'll then put the 40 and the 12 together eventually to get the 52. Is there an easier way to solve all of these calculations? What you can see now on the table are a range of different calculations, but this time set up with visual images. I've used number rods, I've used Numicon, I've used base 10, and I've used the egg box. It's really important when introducing any concept to children, such as double and adjust, that they can see it visually first so that it actually makes sense. In a similar way to the number bonds yesterday, eventually these calculations will be just done in the head. But when we're introducing them, let's get a resource out and let the children see what the calculation actually looks like. So starting over here with 3 plus 4 and 6 plus 7, you can see both those calculations set out using number rods. First thing to look at is, what do you notice when you see those rods next to each other? Hopefully, when you look at 3 plus 4, you can see that the 4 is actually 1 more than the 3. If I was to put another 3 there and then put the 1, what we can now clearly see is that 3 plus 4 is the same as double 3 plus 1. In exactly the same way, when we look at the 6 and the 7, we can see that the 7 is the same as 6 plus 1. So again, what we're now seeing, rather than doing 6 plus 7, we can double 6, which is 12, and add the 1 to make 13. Now, looking at the egg box, the calculation we looked at on the board earlier on, 5 plus 7. I think with the egg box, maybe it's even clearer. You can see the 5 ones over here, you can see the 7 ones over here. But because we've set them out in that particular way, the tens frame style, we can see very clearly that the 7 is 2 more than the 5. So if we want to work out the total, we can put the boxes next to each other, and even move them around that way. What we can now see is 10 and 2 is 12, or we could rearrange them this way. And again, we're still seeing the 10, the 2 is 12. Or double 5 is 10, and 2 more makes 12. Looking at the calculation 7 plus 8, again, you might wish to use Numicon. That's very similar to the number rods, but again, the numbers are a little bit more obvious. With Numicon, we know that's the 7 piece because we can see the 7 ones. We know that's the 8 piece. And if we put the 7 and the 1 there, again, we can see that the 8 is 7 plus 1, so the calculation is really double 7 and then one more. Or we could use a resource such as the Slavonic abacus. You're going to be seeing a lot of this in the training videos over the next few weeks. Love this resource. This one again shows the 7 and the 8. I could separate the 8, so we can now see double 7 plus 1, but even more so we can see double 5 is 10, double 2 is 4, that gives us our 14, and one more makes 15. If the calculation was 7 plus 9, again we can see double 7 plus 2, 14, and 2 is 16. So the Slavonic abacus again a really nice resource to use. Back to the calculation 25 plus 27. And as we talked about when we saw it on the board earlier, the general strategy that children would use, even doing it visually, is to partition. So we put the 20s together, 20 and 20 makes 40, and now we end up with that 5 and 7 again. So the easiest way to do that, double 5, that makes a 10, which I can now exchange. And we have the 5 and 7, which makes 12. We put the 2 together and we end up with 52. Looking at those two numbers, 25 and 27, with the egg boxes, we can actually see the same strategy still applies. We can see 25, we can see 27, and actually we can see that double and adjust really clearly. 25 and 25 makes 50, and 2 more makes 52. It saves you the need to partition if you spot straight away that double and just adjust with the extra 2 at the end.
So as you can see from the examples that we've been looking at, it's really nice to visualize a double and adjust. You can see it with the tens frames. We can also see it with the Numicom. And we can even see it with base 10. These are the examples that we looked at earlier. How do we get children to learn doubles then? Well, there's lots and lots of different ways. Making it as fun as possible is obviously the best way to do it. I often start with children in early years just doing finger doubles, where you hold up your thumb on one hand, your thumb on the other hand, and go 1 and 1 is 2, bringing your thumbs together, and then go double 1 is 2, bringing them together again. Then bring 2 fingers up from one hand, 2 fingers up from the other hand, 2 and 2 is 4, bring them together, double 2 is 4. Again, repeat, 3 and 3 is 6, bring them together, double 3 is 6. That can easily be extended all the way up to 10 fingers using a partner. So if one child holds up 6 and their friend holds up 6, 6 and 6 is 12, double 6 is 12. It's a really nice visual there, similar to the abacus, where the children will see that the double 6 is also a double 5 plus a double 1. So finger doubles is one really helpful way to learn doubling. Another really useful idea is clapping. Very simple. I'll just obviously play the part of the teacher and the class. The teacher claps and shouts a number. 3. The children clap and shout the double. 6, 7, 14, 8, 16, 3, 6, 22, 44, 35, 70, and so on. Now, obviously, if we slow the clapping down, 26, 52. As we move into key stage 2, the children have got a little bit longer to think about it. What's also worth doing, though, is if you're going to use doubles beyond the obvious ones and beyond the crucial ones, it's always worth writing them down on the board so the children can see the doubles that they're expected to use when we do the clapping activity. So, as we've just seen, there are certain doubles that just need to be learned. There's many ways to do this. One of the ways I always think is really good is by using a song. For many years, I've been using Number Fun, written by Dave Godfrey. All of the songs are now available with animations on the Number Fun portal. This is one of them. This is the Doubling Machine song, a really good fun song for Key Stage 1 children to help them learn those vital doubles.
Have you seen my doubling machine? This is how it goes. Put a number in my ear, then the double will appear when I beat my nose. 2, 4, and 4, 8.
As you can see, as well as singing the song, there's a nice little visual using Numicom that appears, showing double 2 becoming 4 and double 4 becoming 8. Again, you can do the song, you can use the instrumental version of this and create your own versions. And obviously, you can use any resource to represent the double. It could be cubes, it could be base 10, it could be egg boxes, or it could be Numicon. I'm just going to move the video a little bit further on, the animation, should I say, so that you can see one of the later versions. What we can see now is base 10 being used to represent doubling slightly larger numbers.
Have you seen my doubling machine? This is how it goes. Put a number in my ear, and the double will appear when I beep my nose. 25, beep, 50, and 50, beep, 100.
As we just heard, Doubling Machine is a great song and one that I use all of the time. Although it generally tends to be used in Key Stage 1, again, there's no problem using it with the backing track in Key Stage 2. Number Fun and the Number Fun portal is a resource I've been using for many, many years, and there are songs on Number Fun that are applicable for all ages from early years all the way to upper Key Stage 2, and even better, they cover all different concepts. The Number Fun songs are all written by a friend of mine called Dave Godfrey, and again, if you ever get a chance to go and have a look at some of the videos or training materials that he's putting out at the moment for Key Stage 1, you'll find them really, really entertaining and really, really helpful. Sticking to the subject of doubling, there are 2 other doubling songs that are well worth a look. Double Trouble is aimed at early years Key Stage 1, and it looks at simple doubles. Double the Breakfast is aimed at Key Stage 2. That's a constant doubling song, where, for example, you start at number 1 and you go double 1 is 2, then 4, 8, 16, 32, 64. And Double Trouble, where you can see 2 children there. Again, children can actually do this in class, which is brilliant, and they can actually work with a partner and pretend to be the doubling monster. The doubling monster has got 10 toes and 10 toes, so it's a 20-toed monster. It's got 4 limbs and another 4 limbs, therefore it's an 8-limbed monster. It's got 20 teeth and 20 teeth, which makes it a 40-toothed monster. And it's got 10 fingers and 10 fingers, which makes it a 20-fingered monster. Again, children can devise their own doubling monsters and come up with their own doubles as well. Altogether, there are well over 200 songs on the Number Fun portal, containing full tracks, backing tracks, the animations, and also a load of teacher resources as well, downloadable resources that support the teaching and understanding many of the concepts. So if you have got a few more hours to spare and you want something to have a look at, I'd heavily recommend getting yourself onto the Number Fun portal and having a look at what's available. Okay, learning doubles. What do we actually have to need to know? What we can see here are all of the doubles that were part of the old national curriculum and the year groups that they were assigned. In the current curriculum, apart from in early years, funnily enough, there's no actual specific objective linked to learning doubles. Halving does get mentioned as part of the fractions curriculum, but it no longer specifies what year group need to learn each double. I think this is quite a nice starting point. You can see in year 1 are outlined in yellow, year 2 in blue, year 3 in green, and year 4 in pink. But actually, a lot of those pink doubles, for example, the multiples of 100, could be learned much, much earlier. Basically, the more doubles that children can just learn and have in their head, the easier it's going to be to apply those as part of a double and adjust strategy at a later date. So if we can spend time working with children just on instant recall, as well as the visuals, which are really important, but actually, do I know double 10? Do I know double 7? Do I know double 12? And then, do I know double 17 or double 19 or double 15? Can I get those established in my head? Once I've learned double 2 and double 4, can I learn double 20 and double 40 and double 200 and double 400? Basically, give them a sheet like this and let's just see how many they can learn and just keep practicing them. All you really need is something like a shuffled up set of 0 to 100 cards. Shuffle those up, turn them over, practice the double. Turn the next one over, practice the double. The great thing with that is you can pretty much have a 1 to 20 pack, a 1 to 50 pack, a 1 to 30 pack, or all the way to 100, and develop that over time with the children that you're working with. There are, though, certain doubles that are absolutely crucial. Without these, actually, it's very, very difficult to move any further with any strategy, especially one such as double and adjust. The doubles that are absolutely crucial are doubles 1 to 10, doubles 10 to 100 in multiples of 10, and then doubles 100 to 900 in multiples of 100. Get those learnt really, really quickly, and that's a great starting point. It's also really useful if children can learn double 15, double 25, double 35, double 45, and double 75. As we're going to see later in the video, we want to look at how they can be used in many, many different ways. As that develops, doubles 11 to 19 are also incredibly useful. And then the other multiples of 5 that we've not counted so far, 55, 65, 85, and 95. Obviously, as we develop through Key Stage 2 in years 4, 5, and 6, the more doubles we know, the better, because they're going to be very, very helpful with doubling fractions and doubling decimals.
Now, having seen the doubles that we really need to know, which I've kind of shown you on the right-hand side there, along with some of the other doubles that it's very useful to know, what we can then start to do is just have a really simple doubling strategy that we can work through with children when we're initially teaching them how to just double any number. Some of them, very, very obvious, double 13, double 24, double 42. If we've learnt doubles 1 to 10, and we've learnt double 10 to 100, then these ones are very, very straightforward. It's just a simple case of partitioning. Double the 10s, double the 1s, and we get 26. Double the 10s, we get 40, double the 1s, we get 8. Double the 10s, we get 80, double the 1s, we get 4. So those ones, very, very straightforward. And again, we can use any resource like the abacus or Numicon or base 10 just to show what those numbers look like. As we move down to the second set of calculations, double 17, 26 and 48, it does get a little bit more complex. If we use the same strategy, double the 10s, which gives us 20, double the 1s, which gives us 14, we've then got to do 20, 30, 4. Again, not too difficult. But certainly, you know, a little bit harder than the ones above. Similarly here, we get 40 add 12, and over here we get 80 add 16, so we get 52, and we get 96. Again, very good skill to practice with the children, helps with the partitioning as well. But is there an alternative way we could do it based on what we've seen before? So, as we looked at before, we can have 17 as 10 and 7, 26 as 20 and 6, and 48 as 40 and 8, but just by slightly altering them, what we can now see is that 17 is 15 and 2, 26 is 25 and 1, and 48 is 45 and 3. That's going to really help us with our doubling. So here's our original answers and how we work them out for double 17, double 26, and double 48. What we can now see is that alternative version, again using the number bonds diagram. We can now see double 15 gives us 30, double 2 gives us 4, double 25 gives us 50, and double 1 gives us 2, double 45 gives us 90, and double 3 gives us 6. So two different alternatives. Again, if your partitioning skills are great and the same with children, then we can just use the conventional way of doubling. But if they've learnt the key doubles over here, then we can use those to help them as an alternative.
As we've just seen, if we learn the crucial doubles, we can use these for doubling almost any number. These are the examples that we've just been looking at downstairs, are very similar ones, where you can see the obvious doubles, the 13, the 41 and the 34, where there's no extra partitioning that needs to be done. And then there's the ones that are slightly more complicated, double 17, double 28 or double 37. As we looked, they can be done in a variety of ways. Double 17 as a 10 and a 7 can lead us to 20 and 14, or double 17 as 15 and 2 leads us to 30 and 4, which is probably a little bit easier. If we see double 26 as 20 and 6, we end up with 40 and 12. If we see 26 as 25 and 1, we end up with 50 and 2. Moving on to the third example, you can see we either get 60 and 16, or we get 70 plus 6. So that little bit of thinking, that sense of number, what's the best way to double a number, can lead us to a variety of different approaches. I just want you to have a quick look at this one, having a look at double 39 and double 97. What would you do? What would your strategy be for doubling both those numbers? I'm going to pause the video for a second, have a look at them, have a quick jotting. What would your best strategy be for doubling 39? What would your best strategy be for doubling 97? Hopefully you've had a few little goes at that one. This is the obvious for double 39. Double 30 is 60, double 9 is 18. For children that are quite quick fire with those, that's probably the easiest way to do it. But what about those children who don't add up 60 and 18 quick enough? Well, in which case, Let's try 39 as 35 and 4. If we've learnt that crucial double 35 is 70, double 4 is 8, total 78. Alternatively, and I presume a lot of people thought about it this way, we also know that 39 is 40 subtract 1. Well, in which case, double 40 is 80, double minus 1 is 2. And again, it still gives us 78. Obviously, number 97 is considerably more complicated, but again, if we just know our doubles, 180 add 14, 194. Is it easier, though, if we change our 90 into 50 and 40? That gives us 100 and 80. Again, probably not, because you probably know double 90, but it's just one other alternative. But the third one is one that's well worth looking at. Double 97, well, 97 is 100 subtract 3. So we'll double our 100 and we'll double negative 3. We end up with 200 subtract 6 and we get the answer 194. Whichever way you do it, you're still going to get the same answer, but this is what sense of number is all about, choosing the method that we think will get us the answer in the most efficient way.
Let's have a look at the number now that I've created with base 10. Can you read that number without me actually writing it down above it? Hopefully, you'll see that number is 278. If I'd have done it like this, it would have been much harder, and you'd probably have had to count the individual tens and the individual ones. You'll notice in all of the videos that kind of tens frame style or 5 style of 5 and a bit. So what you can see now are 278. Now if I was doubling 278, I'd have to double the 200 to get 400. I'd have to double the 70, which would give me 140. I'd have to double the 8, which would give me 16. But what we're going to look at actually as a kind of an extension activity, if you're working with a group of children that are working at a slightly higher level mathematically, is can we do it in different ways? Can we manipulate this apparatus so we can see the number other than just hundreds, tens and ones? So we're going to pause the video in a second. You're going to look at 278 and just think, if I was to rearrange it slightly and put some of the tens together with the hundreds or the tens and the ones in a slightly different way, can we create some other calculations that we can also double to find the answer in a different way? Here's our initial 278, the 200s, the 7 tens, and the 8 ones. All I've done is just rearrange the apparatus so we can see it in different ways. And again, this is a great thing to do practically, and then it's something we can develop as a mental jotting. We can see the second one, which is 250 together, 25 and 3. Or if children find 250 as a double a little bit more complicated, we'll go to the next one, which is 250, 25 and 3. And then, what about those children that have learnt that other double 75? Well, what we've got there is 275 and 3. If we were to double each of those separate bits, let's just have a look at what that will look like up on our whiteboard. These are the sorts of greater depth activities that you can try yourself to get a real sense of number, and that you can also use with children that have developed that sense of number and have started to see that there are lots and lots of different ways that you can play with numbers. Let's have a look at the obvious one. Double 200 gives us 400, double 70 gives us 140, and double 8 gives us 16. Moving to the next one, double 250 gives us a slightly easier 500. Double 25 gives us 50, and double 3 gives us 6. Look at the difference now in the two calculations that we've got to add up at the end. Doing the standard way, we've got to do 400, 540, 556, whereas the second way, we've got those numbers already there, 500, 50 and 6. Let's have a look at the third option. Double 200 gives us 400, double 50 gives us 100, double 25 gives us 50, and double 3 gives us 6. Just a slightly less complicated version of that one. The last version, for those children that do know double 75, why not rewrite it like that? Double 200 is 400, double 75 is 150, and double 3 is 6. What we've proved is it really doesn't matter how you partition the number. You can partition it the obvious way, or you can partition it in a range of different ways. What you're always going to get is the same answer, which is 556. It's probably my favourite part of each day. We're going to move over to the ready-made maths number wall. What we're going to do is we're going to pause the video again. We're going to let you have a look at the number wall, and this time you're going to look at those numbers and think which numbers would go together in the double and adjust strategy. So have a look at them. Can you find pairs of numbers that you could put together and use double adjust to find the total? Here are just some of the potential answers that you could have come up with. Obviously you could have found many, many more, because obviously some of these numbers can be replaced with other numbers from the board. Started off with 11 and 12. Easy way to do that one. Double 11 is 22, and just add the extra 1 to make 23. A lot of children though prefer the double 12 idea, so double 12, 24, and then subtract 1. In a similar way, over on this side, 6 and 7, we can use the double 6 and add 1 more. We can use the double 7 and subtract 1. Either way, you're going to get 13. Moving down, we've got 15 and 17. I think we looked at a similar one to that earlier on. Double 15 is 30, and 2 more is 32. We can look at this one here. Using double 45 is 90, and 4, that is 94. Then we've come to another couple that are maybe a little bit more complicated. Let's move over to this one over here. 108 plus 110. It is a straightforward partition anyway, 200, a 10 and an 8. But what we could do, using double and adjust, double the 110, that gives us 220. Subtract 2 to give us 218. The final one is probably the one that has the most options. What is the near double that we're going to use? Are we going to use double 28 if we know it, and add 1 more? 56 and 1, that is 57. Or are we going to use double 30? Double 30 is 60, and then we subtract 1, 2, 3. A little bit more complicated, but certainly a way that would work. Or are we going to use that really well-known double that we've used all day, double 25? 25 and 25 is 50, add 3 is 53, add another 4 is 57. There's so many different ways, and that's been the point of today's video. When you've got numbers like these, there's so much potential for moving them around, for manipulating them, and for playing with them. That's the point of sense of number, of mental mathematics. It's the ability to look at a number and know that there are so many different things that you can do with it. What we're going to conclude with are 4 decimal calculations. Probably very little difference in doing these to actually doing the 2-digit ones. Obviously though, we're remembering it's not double 25 we're looking at, it's double 2.5. Starting off with 2.5 and 2.7, I've got a visual of that here using the Numicon. Again, it looks very similar to the visual for 25 and 27. What we're now saying is that this piece represents 1 whole, or 10 tenths. So we can see 1, 2 wholes and 5 tenths, or 2.5, or 2.5. And underneath, we've got 2 wholes and 7 tenths, or 2.7. All I need to do is replace that 2.7 with a 0.5 and a 0.2, and what we can now see is double 2.5, and again what I can then do with that, double 2.5 gives me a 5, and I end up with an answer of 1, 2, 3, 4, 5.2. Moving back to the board, we can see that idea, double 2.5, add 0.2, that equals 5.2. Have a look at the other 3, pause the video just really quickly, what's your double and how are you going to adjust it? Fingers crossed you saw that double 4.5, using the idea that double 45 is 90, double 4.5 is 9, and then 0.3 gives us 9.3. These two are a little bit more complicated, but hopefully you can see the link between this one and this one. 12.5 doubled, and then another 0.2. Well, 12.5, double 12.5 is 25, so that gives us 25.2. You can see the link between the two calculations there. And finally, we're now on 3.25 and 3.27. Well, 3.25, and then we've got an extra 2 hundredths over here. So 3.25 and 3.25 will be 6.5. So the answer to that one will be 6.52. So again, similar strategy all the way through, and now applying it to decimals.
The jottings that we've just looked at can also be seen as part of the sense of number visual calculation policy. The VCP is a policy that has a structured approach to teaching all 4 operations using mental methods, written methods, and also showing things in the concrete pictorial. I'll be using examples from the sense of number visual calculation policy throughout all the sessions over the next few weeks. They're absolutely ideal for using on working walls, and they also allow the children to regularly be able to see the strategy that they've been using in a really nice way in which it can be jotted. So again, if you're interested in having a look at those, you can find those at senseofnumber.co.uk.
So thank you very much for joining me for day 2 of the Ready-Made Mathematics mental calculation strategies. Today we've been looking at double and adjust. Yesterday we looked at number bonds, and tomorrow we're looking at the third strategy, which is round and adjust. I I hope you found the sessions useful and that basically you're going to have the opportunity now in your own time to practice that strategy throughout the day. And as we meet the new one tomorrow, we're building up a bank or a repertoire of strategies. So by the end of the week, whenever we look at the pair of numbers, we're going to be saying to ourselves, can I do that in my head? Thanks very much, and I'll look forward to seeing you tomorrow.
And that's it for today. Day 2, double and adjust. So in the previous 2 days, we've learnt number bonds as one strategy, and we've learnt to use our near doubles as our second strategy. We're going to move on to a third one tomorrow. We're going to continue to build up this repertoire of strategies, and fingers crossed, by the time we get to Friday, we'll have got this really cool approach to mental mathematics, where when we see a calculation, our first principle is, can I do it in my head? And we're then going to be thinking on what's the best strategy to use. Hope you've enjoyed today's training, and I really look forward to seeing you again for day 3 tomorrow. Goodbye and see you then.